Having spotted the issue, let's have at it and get this sucker fixed with a virtual link. Also, I'm glad to be bringing this to you because in my courses, I always love including things where I've bumped into in my NA and my NP studies, and I always like to tell people things that I wish someone had told me at the time. And this lab is going to include something that's been left out of every virtual link document I've ever seen. PDF, book, doesn't matter. It's real world, and you're going to get to see it here live in just a moment. But let's go ahead and get our configuration started here, and we can start on router 4. Now, the thing with the virtual link is, it is, a point-to-point virtual link, so it's got to be configured on both ends. You're not just going to configure this on one router. And when you hear that description I just gave you, it sounds like an interface level command, right? You're going to build it through the internet, the Ethernet interfaces. Well, that's actually not the case. The virtual link command is kind of hidden because you do a config T, and if you go into router OSPF mode and you do iOS help here, you don't get anything here that looks like a virtual link, and you're not going to get anything at the bottom because the commands stop at the letter T. There are no commands here at this level that begin with the letter V. So the first time you look at this, and I remember this happening to me, it's like, okay, where do I configure a virtual link? Because if you go out to the interface level, you're not going to see it either. Well, what you've got to do is actually start with the area command. And we know we're going to be asked for the area ID as a decimal or IP address, but the thing is, what area do we want to put here? Are we going to put the area that we are extending to area 0? Are we going to put the area 34 that's between routers 3 and 4? Or are we going to put area 4 because that's the area that we're having the trouble with right now? And the command, the number that you want to put here is what we call the transit area. This is where the virtual link's really actually going to go through. So it's not going to be area 0 because that's where we're going to. It's not going to be area 4 because that's where we're going from. The transit area, of course, is going to be area 34, the physical link between the two routers that we're building a virtual link through. So that's something you got to know because iOS help is not really helping you with that here. Let's bring that back up. We'll put area 34. And there's a little something called a virtual link. It's almost as much fun as a sham link. I just like saying sham link. But we're going to leave that alone for today. Virtual link is where we're going right now. You could just put VIR or something, that would be enough. And you got to watch this one too because your eyes tend to go to IP address associated with a virtual link neighbor. And the thing is, we don't want the IP address that's in area 34. We want the RID. That's what you've got to put here. So if I suddenly forgot what the RID was for that command, what's a good way for me to go get it? Show IP OSPF neighbor. And there's the RID 3333, the address 172.12.34.3 that we expect to see. So let's go back into router OSPF mode, and we'll repeat the command. And just put 3333 here. And we do have other options, but nothing that we have to deal with here. Now, if authentication were involved in our OSPF network, we might actually have to configure authentication on the virtual link. That is not something we have to do here because authentication isn't part of the CCNA. So we can just go with what we have right here, and that's it. So I'll hop over to 3 while we're at it. And almost a mirror command. It's going to be area 34 and then virtual link 4444. And the reason I was mentioning something that you darn well knew already is that I wanted to see this command. This is what I was talking about earlier that gets left out of a lot of materials on virtual links. Now, your eyes go to OSPF4 error received, and then you see received invalid packet, and then you get an ID mismatch, and then you're going to start getting this message every 10 seconds, and you just think, oh, what did I do? Well, the thing is, you haven't done anything wrong. This is not an incorrect configuration. It's an incomplete configuration. You're going to see this message, especially when your transit area is a broadcast segment. You're going to see it, and you're going to see it often, and you're going to see it until you get the configuration finished. Now, if you continue to get this after we fix the configuration, or finish it, I should say, then you do have some kind of issue in your config. But let's go ahead and just finish what we're doing. And we should be fine. Area 34, virtual link, and our ID over there is all 4s. We know that from seeing it earlier. And you might see the message one more time as it's coming in, but if it stops now, then you're fine. And it's looking like we're fine also, since we got a message neighbor 4444 on OSPF underscore VL2 from loading to full. So that's an additional adjacency. And that's pretty wild. Let's go down to 4. And actually we have everything here. We can go ahead and run show IP OSPF neighbor here. And notice that we see 2 adjacencies here, where we only had 1 on router 4 before. This is another one going back to 3, and you can see that it's a virtual link. You see interface OSPF underscore VL2. We did not create that. The process created it. We didn't have to go in and say, okay, interface, you know, like a loopback when you create one of those. We didn't create this interface, but we inadvertently created it really when we created the virtual link. And something else of note here, you'll see a dead time there at first for the virtual link, and then you'll see it actually go to a dash, because you don't really have hello and dead timers for the virtual link, even though you will see it when you go into show IP OSPF interface. And the first one we get is this virtual one that was just created for us. But it's going to give you the IP address of the physical. It goes to area 0, and notice the network type here is virtual link, and the state is point to point. So that's where the initial timers come from, but what you should see is a couple of dashes come up, and that's really it. So we'll go ahead and escape out of that. And really the important thing is to see whether we have 4's loopback, and you can see now that we do. And again, the challenge there was we weren't getting a warning from the router. We just happened to notice it when we were testing our connectivity. And we'll ping 4444. We're perfectly fine. Let's go up 1 router, so to speak, to router 1. Make sure everybody sees it, and we do. And to 5, show up here out OSPF. And we do. So let's go ahead and ping there. And we are all set. Our virtual link is an absolute total success. And how you will usually see virtual links on a network diagram is as a dotted line. You tend not to see them as solids as you would physical connections. I'll show you what that what that looks like in just a moment. But a couple of tips here as far as troubleshooting. If I had not seen the route 4444 there, I would have checked these 3 values, because in my experience they're responsible for 99% of virtual link problems. First off, you're using the wrong RID. That's probably 99.9%. Then you cannot use a stub area. I've mentioned those to you a couple of times. If you have a stub area, you cannot use that as the transit area. Can't do it. Won't work. And then finally, if you have authentication in use, then failure to configure authentication on that virtual link is going to end up giving you some trouble. We didn't run into any of those. Those are more things to keep in mind for the future, especially those last 2. But with the virtual link command and the RID, we know all about the RID by now. And there's our virtual link going through area 34, and that's what made it possible for all the other routers in the network to see that one loopback that we had down in area 4. So thank goodness for the virtual link, because we were going to have a heck of a time getting a physical connection back to area 0 from router 4. And of course, sometimes, especially in real world networking, you can't. Sometimes you just don't have the physical interfaces, so you got to build a logical one. There's always a way to get the job done. Speaking of that, we've got a couple of specialized scenarios coming up, a little more theory as far as the LSAs go and that kind of thing, but also a passive interface command that really comes in handy. That's all coming up in the next couple of videos.